everyone, welcome to today's video on classifying functions as either linear functions or nonlinear functions. So we are in our functions unit and we've already learned what a function is. A function is a rule that assigns each input exactly one output. And we say a relation, which is just a relationship between two variables, is a function, again, if for each input there is exactly one output. So we've already looked at distinguishing functions from relations that are not functions. Today we're going to be focusing on the two types of functions. So we can split all functions up into linear functions and then nonlinear functions. The nonlinear category you can also subdivide into smaller different other types of functions, which you'll learn in high school, but we're not going to worry about those this year. A linear function looks like a line when we graph it. And in particular, one small note is for it to be a linear function, it can be any type of line except for a vertical line. Okay, if you think about the vertical line test, it's a little bit hard to picture, but we know we have a vertical line completely straight up and down. Then if that's our graph, then the vertical line test, we could draw that exactly on top of it. And then for whatever input this was, whatever x it is, say -2, there'd be infinitely many y values or outputs because every single point along that line has the same input. So any type of line except for a vertical line is going to be a function. So any sort of like diagonal thing we have going on, no matter what direction, or horizontal lines. Those are all linear functions. And when we see them in table form, we're going to be able to identify the constant rate of change or the constant slope, the slope of the line. We should remember that slope means the constant rate of change. It means the change in the y values or the vertical change divided by the change in the x values or the horizontal change. So we'll see that a little bit more today and then as we continue with this unit. And then nonlinear functions are just not non-linear functions, meaning functions that do not look like lines. Okay, so in graph form, nonlinear functions are any functions, any graphs that pass the vertical line test and is not a line. And then in table form, we're going to see that there is not a constant rate of change. That's not a slope of our line. It's going to be the main difference. So we'll just see lots of examples today. Here's example number 1, pretty straightforward. Is this a linear or a nonlinear function? This is in graph form, great. So I just need to ask myself, okay, graph form, linear functions are lines, nonlinear functions pass the vertical line test and are not lines. So is this a line? No, not a line. So this is a nonlinear function. For the work we're going to be doing now, we're going to assume everything we see will be a function, but we could confirm that this is a function when I draw those vertical lines. It's only going to cross each point once, thus for each input there's only one output. It's pretty easy with graphs, it's a little bit harder with tables. So if there's a constant rate of change between the x and the y's, the independent, the dependent, inputs and outputs, then we'll have a linear function. And if there is not a constant rate of change, then it is not going to be linear. So to do that, we're going to take a look at our independent variable. This is our input, and in this problem, it's our t. We would also think of it often as x, and then our h is y. T probably stands for like time, and I think h stands for height in this word problem. But we're comparing our independent variable, our input time, with the dependent variable, our output h height. And we're just going to need to find the change in the t values here, the change in the inputs, divided by the change in the outputs for any 2 points. So for example, when I'm going from 0 to 1, that is a change of 1. I'm going up 1. And when I go from 300 to 285, I'm subtracting 15. That's my difference of my h, difference in the height. Okay, that means for those 2 points, I have a rate of change of -15 divided by 1. Okay, so for this 1 second that's gone by, probably 1 second, 1 minute, the height is going down 15 feet, for example. Okay, so that's my change. That's just between one pair of points. So we need to see, is that true for all pairs of points? Because that's what makes it linear. That means we have a constant rate of change. So now let's check here. From 1 to 2, I'm going up 1. From 285 to 270, I subtract 15. Again, then I'm going down 15 feet, for example, in 1 second. Okay, I can do that again here. And then, I don't know, we get to the last one because it needs to work for all of them. This looks a little bit concerning. Now I'm going from 3 to 20. So what is that change? 3 plus what equals 20? Yep, 17. 3 plus 17 equals 20. So that's the change in the x or the t or the inputs. And then I'm going to find the change in my y variable, my h variable. In this case, from 255 to 0, it's getting smaller, so I'm going to subtract or add a negative. I'm going to have to subtract 255. 255 minus 255 is 0. Okay, so if negative 255 divided by 17 is equal to negative 15 over 1 divided by 1, then I have a constant rate of change between all of these points. Thus, I found the constant rate of change, the slope, so this is going to be linear. Or if these are different, then it will not be linear. We just need one counterexample. Okay, so go ahead, figure it out. What is negative 255 divided by 17? It is equal to negative 15. All of these are equal to negative 15. So we have a constant rate of change, when I divide the change in the y divided by the change in the x. In this case, the change in the h divided by the change in the t. So this means this is a linear function. And while we're not focusing too much on it today, since we already did learn the concept of slope, right, this is the slope of the line. So when we go and write an equation for it, which we'll see again in a few days, that's going to be the slope of the line, constant rate of change. Okay, so that's an example of a linear function in table form. Now let's take an example of a nonlinear function. I'm giving away the punchline here. But here for my x's, I'm going to find my changes. So from 0 to 1.5, I'm going up by 1.5, 1.5 to 3, plus 1.5, 3 plus 1.5 is 4.5. Okay, now I want to find those for the y's. From 2 to 5, I'm going plus 3. From 5 to 8, I'm adding 3. Okay, now let's do this last one. 8 plus what is 14? 8 plus what is 14? 8 plus 6 is 14. Okay, so now we want to think about what is the rate of change. How are we changing? So like when x goes up by 1.5, is there a constant amount that y goes up by? So in this situation, x goes up by 1.5, y goes up by 3. Okay, in this situation, x goes up by 1.5, y goes up by 3. So if those were our only data points, we'd say, yes, this is linear, right? Every time I go up by 1.5 and the x, the y goes up by 3. However, once I get down here, when I have an increase in x of 1.5, I have an increase in y of 6. So that is not a constant rate of change. Those are not equal to each other. So this is a non-linear function. There is not a constant rate of change. We cannot find a slope of the line because we don't have that consistent change in y divided by change in x. Okay, all right, so those are the key ideas. Now it's time for you to try. So for you, try number 1. I have A here and B here. Tell me, is A linear or nonlinear function? And then is B a nonlinear or linear function. All right, good job. So a is a linear function. Why? Because this is a line. Our graph is a line, right? And it's a function. It's going to pass the vertical line test. B, that is a function, yes, but it's a nonlinear function. How do I know that? It's not a line. That's all that matters. It's not a line. It is a function because it passes the vertical line test. So linear and nonlinear. Now, go ahead and try one for this table. Remember, you want to find the change in the y divided by the change in the x. And then that's going to be your rate of change. And if it's constant for all of them, then we have a linear function. And that number that you get for each of them is your slope. But if we don't get the same thing when we find that rate of change in y divided by change in x, for each of them, then we will not have a linear function. It will be nonlinear. Okay, so is this linear or nonlinear? All right, so we should get that this is a nonlinear function. There is not a constant rate of change. So the x's, it's all going up by 1. Okay, so that makes it kind of easy. But then if I look at the change in the y, for this first thing, when I go up by 1, I'm going down. I'm subtracting 5. And then over here, though, when I increase by 1 in the x, I decrease by the y in 3. Okay, so that's a difference. Negative 5 divided by 1 is not equal to negative 1 divided by 1. So right away, then, we can say this is nonlinear. But we can continue to see the pattern as well. When your x increases by 1 here, the y also increases by 1. Okay, that's different than what happened up here when we increased by 1 in the x, and here when we increased by 1 in the x. So there's not a constant rate of change. There is this change happening, but it's not the same for every x value, for every point. So it's not constant, so it's not linear. If we were to graph these points, we would see that the points did not form a line. All right, great job, everyone.